Hello, welcome back to Cracking the Cryptic, and as usual you can find all the places where you can interact with us, all the things that I thought had to do with the channel on the link under the video, which will lead you to our Discord and our Patreon content and to our apps and Sven's Sudoku pad and our merchandise and the catalogue of our puzzles. Now, something I didn't know existed was a Reddit thread devoted to, thread's probably the wrong word, a Reddit devoted to Cracking the Cryptic. And I had a look at it today, and this puzzle appears on it, and it's been quite popular. And I thought I would give it a go on the channel just to see. I don't know what we're going to find, frankly. It sounded from the comments as though it wasn't that easy, so that's something to be going on with. It's got a very interesting idea, I think, which is overlapping extra regions. And yeah, I'm just intrigued to see how it goes. It's called 5 Pluses by Udo Spemin, who I haven't heard of, who... okay. Yeah, I was going to say, I doubt that's a real name. It makes me think of Spemin Allium by Thomas Tallis. Anyway, I have just worked out that it is not a real name, and I know what it implies. And I'll tell you at the end if I remember. Yes, that's quite funny. Right, but the rules are relatively, well, there's a few of them, but it's normal stuff. So normal Sudoku rules apply. Identical digits cannot be a king's move apart. Hadn't seen that. So those two can't be the same. The grey circle is an odd digit. There's only one of those. Digits on an arrow sum to the number in the circle. So those two add up to that one. A clue outside the grid shows the sum of the digits sandwiched between the 1 and the 9 in that row or column. So in this column, between the 1 and the 9, wherever they appear, the digits included add up to 4. A black dot joins cells with a 1:2 ratio, so that could be 4 and 8. Each shaded area, cage, or orange line area contains each of the digits from 1 to 9. So we can see that the shaded areas are 9 cells. We can see that the cages, well, I mean, all of these things are plus shapes, and that's why it's called 5 Pluses. But this is one area. And the reason I've chosen to show these with different markings is because our software can't support overlapping cages or coloured regions very well. So that's what we've done. And for each such plus shape, the sums of its 3-cell arms, e.g. row 1, row 2 and column 3, okay, that's one arm of a plus, that's another, that's another. For each plus shape, the sums of its 3-cell arms are either all odd or all even. Wow, okay, no idea how this is going to play out, but those dems the rules. Hope Udo doesn't mind us showing it. I'm going to give it a go now, and let's get cracking. Right, where do we start with this? There's a lot of the standard rules, but not many of each type. So just 2 little arrows here. We've got somewhere in this column is a 149 or 941 group of cells. These two can't contain 9 because the 11 sum in this row has to be either 2 or 3 cells. Okay, and these can't contain 9 either. So in this central box, 9's in one of the circles. Thrilling deduction. Okay, what's up with this rule about the sums of the 3-cell arms are either all odd or all even? Oh, okay. Yeah, okay, if the central digit... No, hang on. I'm thinking that we know the parity of the central digits. Is that right? If the central digit was even... Yes, if the central digit was even, given that the digits 1 to 9, so the contents of every row, column, box, but also of every extra region. They add up to 45. That is the secret, and you knew it. Don't pretend you didn't. Right, if the contents of those add up to 45, and if you were to put an even digit there, it's not going to work. That is because all of these sets of 2, the total of those 8 cells, once you take one even digit out of 45, are odd. And therefore, they cannot all add up to the same parity. If you had 4 odd numbers, they would all add up to an even number. If you had 4 even numbers, they would all add up to an even number. And it would be impossible. So these are odd. All the central bits of the pluses, including the 1 we get given, are odd. I'm using orange for odd. And that, I don't know, does it mean that 1 and 9 have to be on them in this column? I think it means that 4 is definitely in one of these cells. It does definitely mean that. No, it doesn't. 4 could be there with 1 and 9 there. Ah, okay. I think there's some set theory here. Is there? Right. Okay, I'm going to remember that these central cells are odd because I think that's interesting. But what I'm going to do first of all is highlight these 4 rows and columns. Now, these are a set of the digits 1 to 9, 4 times, but that's only true if we count these 4 cells twice. Now, another set of the cells 1 to 9 twice is the plus shapes. So that's, okay, I'm going to colour them yellow. This other set, and where there's a double count in this other set, I'm going to make it orange. Yes, yellow there, that's another set with 1 overlap, that's another set, and now there's 2 overlaps, so those are orange. Right, the 4 orange cells, I think they don't just have the same total, I think they are the same digits as the 4 purple cells. Because if you take, this is right, if you take the 4 sets of 1 to 9 based on row 3 and 7, columns 3 and 7, that means that these 4 purple cells are the, oh yes, I mean, sorry, having coloured all of this stuff, what I now need to do is eliminate the common cells in both sets of digits that I've highlighted. So let's start with the ones that don't have any purple or orange in. 1 blue and 1 yellow in each of these. Let's eliminate those. Now I am left with, trying to ignore grey, with, now what can I eliminate here? I can eliminate 1 blue and 1 yellow, and the purple means I was double counting blue. So we come down to 1 blue in that cell, actually, and in all of these. So there are 4 blues, and if I eliminate here, let's get rid of the blue because that's not relevant, and 1 of the yellows, we come down to 1 yellow. Yes. So those 4 cells are the overlaps of the plus shapes that are the same cells being counted twice in those. These blue cells are the overlaps of the rows and columns that were counted twice. Now I'm just trying to work out whether blue and yellow add up to the, no, they are the same digits because we've eliminated from blue all the digits that were common to blue and yellow, and we're left with those 4. And we've eliminated from yellow all the digits that were common to blue and yellow. So we're left with those 4. So it's not just the totals of these digits, they are the same identities. These 4 yellow cells are the same identities as the 4 blues. Now, next thing to remember is that the blues and that 1 were all odd. And that means the yellows have the same identity and they're all odd as well. And in this orange plus, that means these 4 cells are the 4 even cells. Oh, let's go back to not blue but purple for those. So I can do parity colouring now in blue and orange. So these blues are the even cells. These oranges are odd cells, and they do include 9. Okay, that's good. Yellow and purple are both odds. So they're all orange cells. Now, what next? No, I'm still wondering about this. Oh gosh, it doesn't tell me anything about this sandwich clue, I don't think, except that now I'm convinced that 4 goes in one of those cells, but it doesn't really get anything done. In this row, no, I still don't know whether these are 2 or 3 cells. You could put 2 in even and odd. Okay, 8 can't be on one of these blue cells because it would have 9 in its circle and 1 would have to go there, which it can't do. So 8's in one of those 2. These are 2, 4 or 6. Where does 7 go in the box? Does it have to go in a circle? If it didn't, yeah, I think 7 has to be in a circle, because if 7 wasn't in a circle, it would be on a 9 arrow, which would be 7, 2, 9. Oh, and the other arrow would need 5 in the circle and 3 and another 2. So, okay, that's slightly complicated, but 7 is in the circle. So this is a 3, 5 pair. Right, and the 5 is going with the 7, because otherwise it would be 5, 4, 9 and 3, 4, 7 with a clash of 4s. So the 5 goes with the 7, leaving a 2, and the 3 goes with the 9, leaving a 6. So that's a 2, 6 pair, and now this is a 4, 8 pair. Still doesn't tell me anything about this 11 sandwich. Oh, these are a set of 3, 5, 7. This is the most obvious thing about these all appearing on the orange plus shape. That is a set of 3, 5, 7, 9. Therefore, this, which is the equivalent, is also a set of 3, 5, 7, 9. Does that help? Not sure. I think it does, but I don't know how. I don't seem to be able to use this parity shading that I've done beyond where I've achieved it, beyond this central box. Come on, think about it, think about it. Can't help that that one random cell is odd at the moment. Now, if these added up to the same parity, I was going to say they can both have an odd digit, and then these will both be odd, and then these would all be even. Actually, that's not possible, because that would use up all 4 even numbers in box 3, but this needs an even number on it. It must connect an even and an odd to be connecting consecutive digits. So these can't be odd, they must be even. And here we get one odd and one even in both instances. We get one odd and one even here, and that's odd, so that's one odd and one even. They're all dominoes of one each. Now I don't know that that works up here, but it does work down here for exactly the same reason, because if you made that odd and that odd, all of these would be even, and that would be impossible. So these are even as well. Here we get one even and one odd, one even and one odd. They're dominoes just as up here. And then this is a domino of one even and one odd. Let me take it off there, because everything we found on these arms has been one even and one odd already. So that's handy. Does that work here? Yes, for a slightly different reason actually. If you made these odd, leaving 4 evens here, this won't work because a black dot needs an even cell on it. So again, for these to be the same and to allow these to be the same, they can't both be odd, they must both be even. And again we get a domino here of even and odd and another one here. And that doesn't tell me much about these this time, but again, for the 4th time actually, because even the central plus shows this same relationship, this has occurred. Now, I don't know that it has to occur here though. Those could be odd and all of these can be even, and I'm not sure I can see a problem with that. Counts right for row 3 and column 3. It doesn't break up what's in the top left corner because that's only an odd cell. That can be even or odd on this black dot. Oh, here's a thought about this. Wherever 8 is here, it must go... No, that's not true. Okay, all I'm going to say is the 11 sum is not made up of 4, 3, something. It's either 8, 3 or 4, 5, 2. One side or the other, which isn't very helpful. Okay. Come on, let's find something that gets us going. I mean, there's quite a lot of deductions already, but none of them really to the point, frankly. One of these 3 must be a 9 for this 4 total. Ah, none of them is a 1, because these are from 3, 5, 7, 9. Right, where does the 1 go in this column? It goes at one of the ends with a 4 sandwiched in between. I'm just going to pencil mark that. Now, it's not all that thrilling, but it means one of these is a 9 to make up the sum. So that's not a 9. One of these is, and therefore, since the purples are a set of 3, 5, 7, 9, those are not 9s. Oh, neither of these was a 9 because the 11 sum across the middle would be broken. So that's not a 9. So now we're definitely going to get a 9 in one of these 2 places and a 9 in one of those. And that's like an X-wing on 9s for both the column and the row. The 2 9s in these columns and rows are in those 4 cells. So this is now a 3, 5, 7 triple. That can't be 9 because it's on a black dot. That can't be 9 because we know it's even. So 9 is in one of these 4 cells. And whichever one it's in, on its plus shape, it's blocking 9 out of this cell. I don't know what that means, but it's odd and it's interesting. Now that could still be odd by being a 1. Just works. If that's a 3, 5, 7, that could be a 9. Okay, this can't be odd. Right. This can't be odd, because those would add up to an odd number, and to make those add up to an odd number, that would also be odd. But this can't be odd if that's a 1, because we've got 3 odd numbers there, 1 there, and 1 up. Oh, maybe not 1 up there. No, that would be the 9. You'd have a 1 here, a 3, 5, 7 triple here, and a 9 here. Okay, I can't quite rule that that's even yet. These black dots, they look too symmetric to be helpful. One of these is a 9. This 11 sandwich. There's so little to go on. It's very clever, this. So one of these goes 9, 6, 3, and the other goes 7, 2, 5. Nine, 6, 3, and I don't know what that means for these black dots. One of them can't be a 3, 6 black dot, but the other one can be. Oh, there's so few totals in this puzzle. It's very odd to think this is all going to disambiguate. We've only got the 11, these arrows, and the 4 thing to tell us actual numbers. Now, have I used this 9 X-wing enough? Well, the 3, 5, 7 triple, that was quite interesting. I still don't know that these are even. I mean, I think they are, but I don't know it. Come on, Mark. Think of something that we can actually do in this puzzle. 1, 4, 9. 8, 3 or 4, 7 looks like. Yes, I said that these 11s were either 8, 3 or 4, 5, 2, but of course they could be 4, 7. Didn't think of that one. They just can't be 4, 3, 4, which is not very detailed information. Right. This can't be a 4 because of the 1, 4, 9, and that can't be either. So they're from 2, 6 or 8. But all that says about this cell is it's 1, 4 or 3. I don't think it can be anything else, but that is an annoying array of possibilities. Now, if it was an 8, then we'd have a 2, 6 pair up here. Oh, then that would have to be a 4, 8 pair. If it was an 8. That would be an 8, 4 pair, that would be an 8, 4 pair, and that works fine with that 8, 4 pair. So there's no problem with that. Oh, the king's move. Oh, I forgot the king's move. King's move. Come on, what's that going to do? Surely that's going to do something now. Can I use it? One of those is a 9 and is affecting this cell. Oh, come on, what about the king's move? Maybe I haven't actually got enough information for the king's move to matter yet, in which case it's not such a big miss. But it's close to mattering already. Yes. The 9 X-wing, one of those is a 9. One of these is a 9 as a result of that. Therefore, this is not a 9. Okay, we get some digits. Right. 7, 2, 5, 9, 6, 3. This is not now 6 and 3. This is not a 2. Aha! That can't be a 3 anymore. Or a 7, thanks to that. So it's a 5. What about this? This can't be a 5 now. So, oh, that can't be a 5. This can't now be 5 or 7 using the king's move. This can't be 3 or 5. This can't be 9. That's a 3-7 pair, so this is 5. And now this isn't. In fact, this is on the orange circle, and so is not 5. That one can't be a 7. This can't be a 9. That's a 3-7 pair on the orange plus. Why did I call it an orange circle? So that's a 9. That's on the X-wing. So 3 there, 9 here, 7 here because it's touching the 3, 7 and 3. And suddenly all those digits are done. Now, what about this 11? Oh, first of all, the 9 is in the sandwich here. So we can put in 4 and 1. And I'm going to colour them. 1, 4, 9. Now, do we know? Right, this sandwich. That. Interestingly, I don't think this can be 8. Because then those already add up to 13, and that can't be the sandwich side of the 1. But that would make this 4, 3, and you'd need another 4, which is impossible. So that's not 8, that's 4. I can't do the sandwich. It could be either that 8, 3 or 4, 5, 2 this side. But I can do that much. So it gives me the 4 and the 8 here. Now this is even and can't be 4 or 6. So that's 2 or 8. And that's a pair. And this is now a 3, 6 pair. This has an even number on it, which is 2 or 8. It's not 2 because 1 and 3 have both been gone. So this is an 8, 7 pair, and this is a 5, 2 pair. Wow. 3, 6, 9, 7, 5. This is not 8, and it's even. It's 2 or 4. What about this? It's not 8. Can I do this yet in some way? Don't think so. We have a 7 up here along with 2 or 8. Gosh, that king's move was fascinating. This is 6 or 8 because it can't be 2 or 4. And now the grey one up here, the grey plus, has used its 6, 8 pair. So that's now a 2, 7 pair. This becomes 8. That's a 4. This is 6. This can't be 6, 3 or 2, 1 or 2, 4. It's 4, 8. Those digits are both even. I am here to tell you. It's not a secret. So that's 1 or 9, which is odd. These are 1, 3 or 9, which are odd. Sorry, that can't be a 3. That can't be a 3 because of the king's move. So that's where 3 goes in the row. That fixes 6 and 3 here. And I can colour them. 2 and 7 and either 1 or 9 still to place here. Interesting, can't do it. Wow, this has unfolded suddenly. Or maybe it's not that sudden. Maybe it's taken quite a while, but it feels a bit sudden to me because I'd forgotten this king's move. And it only just has started to matter, I think. This is not 6, 8 or 4 and it's even. That's a 2. So that's a 4. So this can't be 2. It's 1 or 8. This is 1, 2 or 8. One of these is a 1. 3, 2, 5, 4, 7. Oh, we've had 2 in the plus. So that's not 2. That's a 1, 8 pair. This is a 9, 6 pair. So there's no 9 here, and that's been true since we got a 9 there. These are from 1, 4 and 8. And now I know one arm of this is odd, even, odd. I think all of the arms have 2 odds and an even. So that's even, and it can't be 2, 8 or 4. That's really useful. That's a 6. The 4 and 8 are in those cells, so the 2's over here somewhere. That's become an 8 now. There's got to be a 4 over here, and I know where it goes. It goes there, that's blue. This is the last digit in its plus, it's a 1. That makes this a 9. That makes this a 1. We've got a 2-5 pair over here now. I still don't know. Oh, yes, I do. 8 is looking at that cell by King's move. So there we go. All the arms are done. Every one of these pluses has an odd even pair on its arm, or in the 2 cell bits of the arms. Now this can't be 6-3 or 8-4 or 1-2. It has to be a 2-4 pair, and that fixes the 5-2 at the top. This is a 3-7 pair. The 1-8 pair here has been done. Any other clues? Yes, 1 here, 2-7 pair to go in here, 6-9 pair this side, 5-7 here. Okay, I'm going to take out all the colouring because I think the rest is just numbers now. So I think we've done with our useful colouring. Yeah, there we go. So this is a consecutive pair, and we can't use 1, 2, 3, 4, 7 or 9. We've got 5, 6 and 8 left. That is a 5-6 pair. So that fixes 7-2, that fixes 7-8. This is an 8-9 pair. This is a 2, has been for ages. 7-3 has got fixed. This 6-9 hasn't been, nor is this 6-9. This is 3 or 9 because it's odd. This is our kind of last disambiguator, I think. Oh, and I don't know what to do. Okay, 1 in this column. Can't be in either of those cells because of 1 being there and the King's move. So we get a 1 here. That is a naked 5. This is 6 or 9, but it sees a 9 by the King's move. And that's going to fix all of these 3, 8, 9. All the bottom 4 rows are done. This is a 1-5 pair. This is a 2-7 pair, but the 7 sorts them out. This is a 4-3 pair that we will resolve. 2-7 has sorted out this 2-7. This is very clever, actually. I am very glad to have been doing this puzzle. We've got 3, 4, 6, 9 as a quad up here. We might get some idea of how this odd cell has come into the construction, actually. Oh, am I missing a King's move again? I must be now. There's not many to miss, though. 2, 5, 7, 1, 8. These are from 3, 4, 6, 9. We can't have 3 in those cells, and we can't have 4 in that one. How's this going? Oh, the 11 clue. Yes, it wasn't that side. It's this side. 8 and 3 makes 11. Oh, I forgot that. 9 there, 3 in the circle, 6 there, 5, 6, 5, 1, 8, 1. I love this. This is so clever. The 8, 9 is fixed. Yeah, the 3, 4 is fixed by the 3 in the circle. Not 3 in the corner, but 3 in the circle, retaining its religion. I'm quite pleased with a half-hour solve on that puzzle. That's really interesting. Well done, Udo Spemin. And I will now reveal that I worked out at the beginning that that is an anagram of the word pseudonym. Something about those letters. Well, for many years, one of the Spectator crossword compilers and a close friend of mine has been known as Dumpy Nose, which was a pseudonym he came up with when he started working for the Spectator crossword, and it is itself an anagram of pseudonym. So Udo Spemin has come up with a different one that sounds a bit like a possible name, but isn't. It is an anagram of pseudonym, and that is a really nice puzzle. Very good. So glad we've had a go at that. That's an interesting one. And as always, thank you for watching the channel. I hope you enjoyed having a go at that puzzle. Maybe you did it a slightly different way, or maybe remembering the king's move earlier. I don't think it can have meant you didn't need that 9 X-wing. That was not only quite important, but really important to actually get numbers in the grid. And then suddenly it started to flow. Really nice. Enjoyed that a lot. Okay, see you again soon on the channel. Bye for now.